All right, now that we've got all of that lovely whiteboarding out of the way and we have a game plan in our mind, let's go ahead and get our hands dirty and start coding. Now, like I said in the last video, we were going to kick things off by video number 1 here, as far as coding is concerned, getting a project established, getting our textures copied over, getting our classes created, putting our fields in place inside the game class, initialization, graphics loading, actors list. In fact, we're going to get the actors class done in this video here, and then make sure that we can see a wall graphic in the or not a wall, but a background graphic when we launch our game or our application at the very end of this video. So that is our objectives. Logan.
All right, well, let's begin a new project. This will, of course, be a Windows game, and we'll call the game Laser Bikes. Laser Bikes. And laser is apparently... There we go. All right, a little bit of spelling. Laser Bikes is the project. And the first thing we need to do with the project is very similar to all of the other ones. We'll get some folders set up, some textures added, some classes added. So let's begin with the 2 folders. The first folder we'll call Textures, and the second folder we'll call Classes. Now the textures I have located in our working folder on the C drive, so let me copy those. Then we can go over to our projects directory where we have the newly created Laser Bikes project. Inside of this project, we now have a textures folder, and that is where we'll place the graphics.
And let's stop for just a second. Let's take a look at these. Remember I said that there were going to be 9 different textures when we went through the whiteboarding process in the last video. So here we are. We've got the background, the bike, and the tail. And then all of these other ones are the textures that are going to end up inside that array I was talking about, where we've got a wall horizontal, a wall vertical, and then we've got our top left, top right, bottom left, if we were to go in a clockwise starting from the upper left-hand corner direction. So there's all 9 graphics. So that's what we're going to be working with.
All right, and back in Visual Studio, we need those referenced under the Textures folder. So we'll add some existing items, jump under Textures, show Content Pipeline Files, and select all of the textures. All right, next thing we need to do is to add the classes themselves to the Classes folder. So let's go to Classes, add a new item. The first class is going to be the Actor class. The second class is going to be the Bike class. And the third class is going to be the Wall class. And that makes up our 3 classes. Now, while we have these classes here, let's go through and clean up the namespace and add the necessary using statements to them. Let's begin an Actor, and we'll take out the using for system.txt. We won't need that. And instead we'll put in a using for Microsoft.xna.framework and also for framework.graphics.
Of course, we're going to go ahead and leave collections in place because we will be using a list inside of Actor.
Right. Now under the namespace, we'll remove the classes subnamespace, and then that takes care of the basic setup for Actor. From here we can move over to Bike, though before I do, I'm going to copy the 2 lines for using XNA.framework and framework.graphics so that I can paste them into Bike. Now Bike is not going to use text or collections, so I'll erase both of those and replace them with framework and framework.graphics. We'll also remove the class's subnamespace, and then the Bike class itself needs to extend Actor, so we'll drop that in here. So Bike extends Actor. Now the last class we have is the Wall class. We'll do the same thing with the using statements. We'll replace those with framework and framework.graphics. We'll remove the class's subnamespace, and Wall does not extend Actor, so we're not going to add anything for inheritance, though we are going to mark this as a static class. Everything in Wall is going to be static.
Why, Logan?
Well, we don't ever want to have to create it. It's more of a management class than an instance of anything that's going to exist in-game.
Exactly. Bottom line is, well, there's always going to be walls in this game. That's or the ability to create walls, because if you've got a player, he's going to be moving. I mean, if you had 2 stopped players, then what's the point of the game anyways? So we're always going to have
really,
walls.
the wall is broken up into segments that fill the grid spaces.
Right.
And so wall is the management of those segments.
Exactly.
All right, I'm going to build briefly, just to make sure that there's no very basic syntax errors, and to get all these classes saved.
All right, let's go ahead and jump back over to the game class. And before we move into fields, let's go ahead and get the game state into place, because that's obviously going to be important, because rather we can be playing the game or the game stop because we just collided with a wall or one of the sides of the screen.
Also, we need the type defined before we try to make a field for it within the game class.
Exactly.
So the very first thing we need to look at is our game state enum. So we have game state, enum game state. And we're going to keep this very simple for the engine. We're only going to have two states, playing and stopped. And we'll have collisions trigger the stopped state, and that's how we get that freeze effect whenever a collision occurs. So our two states are playing and stopped. Alright, now we can look at the game class itself. And the first thing to do inside of the game class is to set up all the fields that the game class is going to use. The first of those is going to be the sprite batch, because of course this is a sprite-based game, so we will need one in order to draw. So we'll make our sprite batch field named sprite batch, as we've been doing thus far. Now we can start looking at some of the LaserBike specific fields, beginning with the screen width and screen height. This is the overall screen resolution for the game. I'm going to define this field as a public constant integer called screen width, and we'll set that to a width of 640. Now I'm going to copy and paste this line and adjust the second line to be screen height. And the screen height will be 480. Now after the screen width and height, let's define some constants that describe this grid we've been talking about. We'll have things like a block size for the grid, and then also what is the overall grid width and height. So since these are also going to be public constant integers, I'll just copy one of these lines, paste it in, and change the name. The first grid description, you could say, is the grid block size. And grid block size is going to be set to a value of 8. So each of these grid blocks are going to be 8 pixels wide each.
Yeah, just as a quick reminder, I'm just going to jump back and forth a little bit here and there. So what Logan's talking about is, if I can get that guy moved back down there, is that each one of these blocks right here, we're dealing with 8 pixels.
What we've just defined is that we want those blocks to be 8 pixels wide each.
That's right. Okay.
So with that in mind now, and I guess another quick reasoning for using a value of 8 here is 8 divides nicely into a lot of common screen resolutions. Divides very nicely into 640 by 480. Also works well on higher resolutions like 1280 by 1024 and 1280 by 720.
Yeah, let's go ahead and take 640 and divide 8 into that. So we come up with 80. And this is going to be very important because when we go to put this array together, we're going to need to know exactly how many elements we're dealing with in the x direction and how many we're dealing with in the y direction.
And that's very important because we want to fit our grid into the same space as the screen itself occupies. We want our grid size to match our screen size. So it's very important that we have values that will divide evenly.
Exactly. And what Logan's saying there, just to kind of break that up or back that up, is we want to know exactly how many of these blocks are going to need to fit in there to fit, well, accurately all the way across, nice and snug, until we fill it up nice and neat like such. And so that is where these next two fields are going to come into play.
All right, the next two fields are going to be grid width and grid height. Let me copy and paste this line a few times so we can define these fields. That is grid width and grid height.
So this is not to be confused with pixels. We're talking about how many blocks across, how many blocks up and down.
Exactly. Now, as we just looked at in Calculator, we know what the grid width is going to be because we divided 640 by 8. That gave us, what was that, 80? Or did we divide 4? I can't remember which one it was.
I thought it was 640 by 480.
So 640
or 640 by 8.
Yeah,
80.
640 divided by 8 is 80. Well, hey, if I'd remembered multiplication, I would have known that, but that's beside the point.
8 times 8, 64, but that's okay.
So we know we want a grid width of 80. We've just found inside the calculator that that would match up our screen width of 640 by the 8-pixel block width. Now, we could hard-code the values and it will work, but that would make it a little bit more tedious when we start changing screen resolutions. We would always have to remember to update the grid sizes accordingly. Now, knowing that 8 divides nicely into a lot of common screen resolutions, we could do this calculation as the field is initialized. So we could do essentially the same things we just done in Calculator. We could take our screen width, we could divide that by the grid block size, and that, as we'd found in Calculator, would give us 80, which fits the screen. Then we could turn around and do the same thing for the grid height, where we could take the screen height and divide that by grid block size, giving us a value of, if I remember correctly, 60. And I could check that real quick. So if we took 480 divided by 8, that gives us a value of 60. But that means our grid width and grid height is set automatically. If someday we change this to another screen resolution that's divisible by 8, our grid will auto-accommodate for that new screen size.
Exactly. All right, next thing we're going to take a look at is some fields that are going to be in place for the bike's movement.
Right. These are going to be gameplay-related settings that describe how the bikes behave. These are going to be public static fields. The first is going to be a double. That is called bike move interval. Move without an arm. Bike move interval is going to be set to a value of 0.05. And let's see, let me drop the rest of these in, and I'll give a quick description as to what they do. The next field is going to be bike stop threshold. And bike stop threshold is going to be set to a value of 0.2. And then one more field. This field is going to be a vector 2, and it is going to be the bike origin. Bike origin is going to be set to a new vector 2. The vector 2's components are 6 by 18. All right.
Just a quick reminder to everyone where from time to time you'll see, well, what I like to call magic numbers. And remember, this is more of a proof of concept with the creation of this engine, where we're not looking for the ultimate and most optimized methods of doing things. We're just looking to get the point across and how to put this engine together. Just a quick reminder.
Right. So, quick description of these fields. The first we have is bike move interval. And if you remember, we were talking about a move interval that is to be used with the timing of the grid movement, meaning how much time has to pass before the bike can advance a grid block. And that's going to be represented by bike move interval. That means 0.05 seconds has to go by, has to elapse before the bike will move another grid space. The bike stop threshold is something we only touched on lightly. We had mentioned that the bikes can be stopped using the right trigger as a brake. So as you begin to apply the brake, the bike slows down. And if you push the brake in all the way, we want the bike to actually stop moving on the screen. Now what we had done is, since we have this timer that has an amount of time which must elapse, there is no hard stop point. That means we could set it up to 1 second and the bike would move very slowly. A whole second would have to go by before we advance a block. That would look stopped until that second elapses. Now we could do something like set it to 1,000 seconds, and then it would look stopped. But the problem is, if we have our range going from a movement speed of 5 all the way up to a stopped value of 1,000, 1, it's still not technically stopped. It could eventually advance. And 2, we have this huge range on the trigger, which means that takes up almost all of the useful ranges in the first fraction of a press.
Right.
If we define a stop threshold that is respected inside of the bike, what that means is we can give ourselves a usable range from this threshold to the move interval to give kind of a minimum and maximum speed value. And the bike origin is used as the center point on the bike and tail textures. The value of 6 is going to be half the width of that texture. The texture we're using is 12 pixels wide. 18 is a little bit in front of where the tail starts. The tail section of the graphic actually starts about pixel 20. 18 gave a slightly nicer look to the overall rotation of the bike as it changed direction. Now granted, that was a very small amount and would probably be not noticeable. If you wanted, you could just pick the pixel that the tail actually starts at and use that for the division point or the rotation point on the bike itself. Alright, that takes care of the bike's movement and origin.
Okay, now what we're going to do is move into the fields required to hold our texture. So we've got the bike texture, tail texture, background texture, and then our array of wall textures.
All right, these are all going to be public static fields as well. They'll be of type texture 2D, and I'm going to start with the background texture. So the first we'll have is texture 2D background texture. And now I can start copying and pasting this line a few times. So the next texture we have will be the bike texture, and then the tail texture. Then we're going to have a texture 2D array. The reason we're going to set this up as an array is we had noted that different styles or different grid blocks could be associated with a texture index. If we make that index 0-based, it will fit nicely in the range given by an array. So that means for our wall, we could define this as a texture 2D array and call it wall textures. And another thing we could do, since we're describing or creating fields here that describe graphics, let's also put together an array of colors that can be used to store the different player colors. So we can make a public static color array, which we can call player colors. And I'm going to initialize this here, because wall textures isn't going to be initialized until we actually start loading textures. Colors are just data, so we could create that data here. So we could make a new color array and then set the individual elements, where element 0 could be a new color with the value, let's say, green for the for player 1. So 0 to 55, 0. And player 2 can have a color value of red, or 255, 0, and 0. And then we end off the array, and we can terminate that statement. And this way we have colors stored conveniently. So later when we're working with the player index, we can cast that and use the casted result of 0 or 1, or even expand this later to add more players in order to get the 4-player version of the game. Alright, just a few fields left now. We need to remember what the current game state for this game is, so we'll make a private static game state variable, or excuse me, field. So game, the type will be game state. There we go. A lot of things are named games, so IntelliSense wasn't quite sure which of those to use. And the field itself is going to be called game state as well. And 2 more fields that are not strictly necessary for the engine itself, but could prove useful in the creation of an actual game, and that would be to hold a reference to the bike owned by each individual player. So we'll make a few fields of type bike called player 1 and player 2. And a quick note about the game state. You'll notice the game state is being made static. The reason it is I want to be able to call back to the game from within a bike. What I'm going to end up doing is call a static method, and having the field itself also be static means we have an indirect point of referencing it. That way we don't have to know about the instance of game. We can just look at game in general and access the static field. And that takes care of all the fields necessary for game. Now we could skeleton in a few extra methods that are going to be needed to do things like initializing the scene and checking for collisions or handling collisions. So what I'm going to do is skeleton in 2 methods, a create scene method and a collide wall method. Create scene is going to be a private method. So I'll have a private void create scene and a public static collide wall method. Public static void collide wall. And we'll get back to those probably very shortly. Now we can take a look at the constructor and set the screen resolution by looking at graphics, the graphics object, and setting its preferred back buffer width to be equal to the screen width, and the preferred back buffer height equal to the screen height. So there's preferred back buffer height, which will set to screen height. And that takes care of setting the screen resolution. Now we can turn our attention to the initialize method and create the sprite batch and do a call to create scene. So we'll take our sprite batch and set that to a new sprite batch. Sprite batch, of course, needs to see a graphics device, so we'll feed it graphics.graphicsDevice. Now we'll make our call to create scene, and let's also set the game state. We'll say the game state will start out at a game state of playing. Now I know a game state would otherwise initialize to playing automatically because playing is the first element in the game state enum, but it's nice to set it explicitly here, so if we ever change this enumeration to have something that comes before playing, we won't accidentally break our code. Alright, moving on from here.
Like a title screen.
Exactly. If we were to put a title screen in first, because it happens first in the game, we still don't want to immediately break the code.
Right.
All right, moving down, the next method we can address is load graphics content, where we can load in all of our textures. So let's start with the background texture. Background texture will use the content instance, the constant object, to load a texture 2D. That texture 2D's asset name will include the textures folder, and we are looking for the background texture. And now we can copy this line a few times so that we can put into place our bike texture, loading the graphical asset bike, and the tail texture, loading the tail asset. Now for the wall textures is an array that has not been initialized yet, so we need to do that before we load the textures themselves. So we'll take wall textures and set that equal to a new texture 2D array with 6 elements. Because again, we have 9 textures overall, 3 of them are the background, the bike, and the tail, so that leaves 6 for all of the wall segments. So now that the array itself has been initialized, we can take each individual element, so starting with element sub 0, and load in textures. And I'll very quickly steal the content.load line. And the element 0 is going to be the horizontal wall segment. So wall H will be loaded into element 0. Now I need to copy this and paste it 5 more times. So 1, 2, 3, 4, and 5 for a total of 6 elements. And then we'll number the elements very quickly. Now element sub 1 is going to need to be the vertical wall. 2 is going to start on all of the corner pieces. And again, the corner pieces start at the top left corner of an imaginary square and progress clockwise around the square. That would make element sub 2 the top left element, or that would be wall underscore top left. Advancing clockwise, we would have top right, followed by bottom right, and finally bottom left. And that will have all of our texture data loaded. Now we can move down and we can address the update method. And inside of update, what we'll do is we'll we'll establish the game state switch. So we'll create a switch statement that will switch on the game state field, and we'll drop in our cases for playing and stopped. So we have a case for game state.playing, ended with a break, and a case for GameState.stopped also ended off with a break. And we'll get back to update as we have things that can actually be updated. Moving down from that, let's look at draw. All we're going to do for the time being is draw the background, but that does give us a good opportunity to put in our calls to spritebatch.begin and end. So we'll start with spritebatch.begin. Then we could draw our background. So we'll take spritebatch, tell it to draw the background texture at the position of 0, 0. So let's take a look at vector2, maybe just vector2.0, and use the color white. And once we have our background drawn, we can make a call to spritebatch.end, and we should have our background drawing. As a matter of fact, I believe I can build and test. We see a screen of 640 by 480 with the background drawing, so that's all working very well. Now, before we end off this video, I do want to get the actor class fully fleshed out, since it is a very simple class, but it gives the foundation, the groundwork that we need for some of the update code, and that makes the rest of the classes easier to work with. So let's jump over to actor and let's flesh it out. Inside of actor, we're going to have 3 fields. The first of which is going to be the actors list. This is going to be a public static list of type actor, and it's going to be called actors. The other 2 fields are going to be position and origin. And a quick note on fields throughout this laser bike engine, we're going to continue to follow the principle of very simple fields. That means any field that is used with no further calculation will be public, we're not going to put a private and then a private field exposed by a public property. The only case in which we'll use properties is when we need additional calculations to take place. So that means the position and origin of an actor are going to be represented directly with public fields. So we'll have public vector2 position and public vector2 origin. Alright, now a few methods we have here. We'll have both a static and public constructor. So I'll have a static actor. The static constructor is going to be responsible for creating the actors list. So actors will be equal to a new list of actor. Then we'll have a public constructor. The public constructor is responsible for making sure that this actor gets added to the actors list. So I'll look at the actors list, tell it to add this instance. Then two more methods. We need to have a virtual update and draw method so that we can look at actors in a very generic sense back in the game and then override those methods as necessary. So we'll begin with the public virtual void update method. Update is going to take in a game time parameter. And I'm going to drop the brackets just off to the left since we're not going to provide an implementation inside of actor itself. And we're also going to have a public virtual void move, or excuse me, lost train of thought.
Yeah,
draw method. Draw is going to take in a sprite batch. And again, we're not providing an implementation here inside of actor. It is created just to define it in actor.
Right.
So let me build and make sure that this has not introduced errors, which it has not. The build succeeded. That means we can finish off a last few things inside of game. Now that actor has some abilities, we can go into the back to update under the game state switch and create our actor loop. And then inside of that, look for actors and call their update method. So inside of playing, let's make a reverse for loop. I'll use the for reverse template, and then we'll loop backwards using actor.actors.count to drive the loop. And inside of this loop, we'll make a more convenient variable called actor, which will be equal to actor.actors sub I. Then we'll take that actor and update it, giving it the current game time. And then we'll make this loop a little bit more advanced later when we start getting into input handling. But for now, that does indeed have all of our actors in play where each actor gets updated. And one last thing we could do is address draw and make sure that all actors get drawn. So we could make a for each loop. So for each actor in the actors list, you take that actor and tell it to draw, giving it the current sprite batch. And one last build and run. And we have no actors, so we don't see any effect from that code, but we have the base infrastructure in place so that when we start creating actors, we don't have to go back and worry about some of the tedious baseline stuff.
Exactly. Okay, fantastic. And with that, that is going to wrap up the first of 4 parts for coding in the engine for laser bikes. So let's go ahead and move on to the next video.